Today, we're going to try something a little different. We're going to connect two worlds that honestly couldn't seem further apart: the basic plumbing of the internet and the, well, brand new world of artificial intelligence. We're looking for a common thread, a shared blueprint that underpins something we all need: trust. So let me just ask you this straight up. What on earth does your Wi-Fi router have in common with a powerful AI? I mean, one just shuffles bits and bytes around so you can watch this, right? And the other, it feels like it's actually thinking. What's the connection?
Well, here it is. They are both built on an invisible but incredibly strict architecture of rules. See, one set of rules tells a packet of data where to go, and the other tells an AI how to make a decision. And understanding that they share this foundation, that is the absolute key to trusting either of them.
Okay, so let's start with something we all use every day, even if we don't think about it. We're going to look at the rules of the road for data. This is the world of computer networking, and it's what makes pretty much everything you do online possible. You know, every single time you send an email or just load a web page, your data goes on this amazing little journey. And the very first thing that happens is a process called encapsulation. The best way to think about it is like your data is getting dressed for a trip. It starts out as just your message, but to get where it's going, it has to be put inside a digital envelope with addresses and all sorts of instructions attached. And this whole dressing up process, it happens in layers. So at the very top, the application layer, that's you writing your email. Then, as it travels down, the transport and internet layers wrap it up in something called TCP/IP headers. Think of those as the digital envelope and the specific street address for its big trip across the world. And finally, way down at the bottom, the network access layer turns the whole thing into electrical signals or radio waves. Every step adds another piece of its travel outfit. It's pretty cool. And along its journey, all these different devices are making split-second decisions based on those rules. You know, an old-school hub is super simple. It's basically just shouting the data to everyone, kind of like someone yelling in a crowded room. A switch, though, is a lot smarter. It's like an office mailroom. It looks at the local MAC address, that's a unique ID for your device, and delivers the packet only to the right desk. But the router? The router is the real MVP. It's like the city post office, reading the global IP address to send your data clear across the planet. So here's the big takeaway. Our trust in this whole system, it comes from these built-in, hard-coded rules. Firewalls are like border guards, checking every packet's passport. VLANs create these separate, secure lanes on the digital highway, keeping traffic from bumping into each other. And of course, encryption scrambles the data so nobody can listen in. Trust isn't some happy accident. It is literally designed into the architecture. Okay, so we've got the rules for moving data. We get it. Now let's pivot. Let's talk about a much newer and way more complex challenge: setting up the rules for how an AI interprets all that data to make decisions. The rules of thought, if you will. And I mean, it just makes sense, right? If we need such a strict set of rules to trust a simple packet of data to get from point A to point B, then we absolutely need an even stronger framework to trust an AI with something important, like a medical diagnosis. And that framework? That's what we call the pillars of responsible AI. Now, what's so important to understand here is that these aren't just, fuzzy, nice-to-have ideas. They're actual technical requirements. Fairness means you have to actively work to find and remove bias in the data. Reliability and safety means the model won't just crash when it sees something weird. And transparency means we know exactly what data went in and what the system can and can't do. These are the foundations. And the next set of pillars? Well, these are really all about us, the humans. Inclusiveness means the AI is designed for everyone, no matter their abilities or background. Accountability means there's always a person who's ultimately responsible when things go wrong. You need that human in the loop. And then there's this last one, explainability. And that is so, so important that we need to look at it all by itself. Okay, you have got to understand the difference between these two. Transparency is knowing what is inside the AI. It's like having a list of ingredients for a cake. You know there's flour, sugar, eggs, all that stuff. But explainability, that's knowing why the AI made a specific choice. It's like having the chef tell you exactly why that pinch of salt made the chocolate taste so much richer. It's the difference between just knowing what data was used and getting a clear, human-readable reason for why you were denied a loan. See the difference? It's huge. All right, we've looked at the rules for networks, we've unpacked the pillars for AI, now for the grand finale. Let's put them side by side and reveal the shared blueprint for trust that's been hiding in plain sight this whole time. So here it is, the core idea of this whole explainer. It turns out that the fundamental principles we spent decades developing to trust our computer networks, ideas like integrity, access control, and transparency, are the very same principles we now have to use to build trust in artificial intelligence. It's the same foundation. And just look at how beautifully this all lines up. In networking, we ensure integrity by checking every single piece of data for errors. In AI, that exact same principle is called robustness and safety, making sure the AI's output is reliable and not garbage. For access control, networking has firewalls to decide who gets in. Responsible AI has accountability and a human in the loop to make the final call on big decisions. And finally, transparency. In networking, we use simple tools like ping to see if a connection works. In AI, that need for visibility is met by explainability, showing us the why behind a decision. It's the same blueprint, just for a much more complex machine. So I guess that leaves us with this final question. From a simple network packet to a complex AI making life-altering judgments, the blueprints that run our world are getting incredibly complex, incredibly fast. The real challenge for all of us is making sure that our principles for building trust, integrity, control, and transparency are keeping pace. Are they?